In this week, we've learned about strike, dip and dip direction, and the right-hand rule for measuring the orientation of planes in rocks. For lines, plunge and trend are the relevant quantities. A great deal of basic exploration depends on knowing the orientation of fractures in rocks, which are some of the most common planar features. We've seen that fractures in rocks can be man-made, commonly forming along planes of prior weakness, or natural. Fractures can open perpendicular to their plane. These are called extension fractures. Movement on fractures can also be parallel to their plane. These are shear fractures. If we have both perpendicular and parallel components of movement, these are extensional shear fractures. If it's not possible to determine the direction of movement, we call the fractures joints. Many fractures form in rocks due to stresses. These are tectonic fractures. Other fractures form from fluids under pressure. These are hydrofractures. Fractures also form when igneous rocks cool down and by exhumation of rock. We call the latter exfoliation fractures. Now, fractures create permeability in rocks, allowing fluids to flow through them. Where fluids precipitate minerals in fractures, we form veins. The textures of veins can tell us about the conditions in which they formed, whether, for example, the veins formed in open space, or whether there was a component of shear along the fractures. Fluids also allow rocks to dissolve along wavy or irregular surfaces called stylolites. Stylolites and veins can be very important in the formation of mineral deposits.